So welcome to Fresh Consulting, everyone. We are an innovation company working across digital and hardware solutions and AI and ML. My name is Craig Bearwalt. I'm a hardware solutions manager here. Actually, if you're from Fresh, can you stand up real quick? Just so we got Marco, John, they're on a robotics team, Dan Myers on the business development team, and we got Matt in the back, who's another business development manager like myself. So Fresh, we've been around since 2007. I've been here 90 days, so I had to double check that for a quick second. 380 employees, but we can help you with anywhere along the line, whether you need help in a specific engineering discipline, you help telling the story of your program through the digital side, or maybe you need some help on the AI and ML vision side or some other application on the sensor side. So that's a quick note on Fresh. And I wear another hat, which is Executive Director of the Northwest Robotics Alliance. So just giving a quick update, we put this presentation together about a month ago, talking about the state of Northwest Robotics. Next, oh, there's a clicker here? Okay, there we go. Okay, perfect. So Northwest Robotics Alliance was founded by Fresh Consulting, Cascadia Capital, and Moderator, which is the largest VC in the Pacific Northwest. So we have monthly networking events to share ideas like this and make connections. We mash up technologies to make them move faster. Last month, we did a celebration for First Robotics, building the ecosystem of STEM-related jobs and creating those jobs and building the workforce is extremely important. And then we also talk about policy issues. Automobiles have been roaming the roads for over 100 years, but when you take a robot and drive it on a sidewalk, you have all sorts of new problems, right? Or new issues that need to be resolved. Policy issues like, hey, what happens when that robot crosses from one municipality to the other? Do you have common laws, et cetera? So we're here as an industry organization to help support that. And then, kind of this networking to match job seekers with companies. So this is really awesome. A lot of big numbers here. There's a lot of awesome stuff going on in the Northwest. One thing about the Northwest is we are kind of, when you take Vancouver, Seattle, and Portland, I think you have to go 1,500 miles before you hit another major metropolitan area. So we are a little microcosm there. Obviously, with Amazon and everything they've done in robotics, we've absorbed all sorts of robotics country all over the globe here in the Northwest region. So what is a robot? So our definition of a robot is a machine that's able of doing a series of complex maneuvers in an ambiguous environment. And the one thing I want to point out here is that robotics is a really wide topic. I've mentioned to several of you already tonight that you could have we could have a topic every month be different and never repeat for the 100th month because we got ag tech and marine robotics, et cetera. And in this case, robots do a lot of different things. In the upper left, you see a FANUC type robot in an industrial application. The next, but it's picking something. On the right side, you see a fruit picking robot that's out actually working in the orchards, et cetera. So two different environments doing two different tasks that have their own unique constraints. On the middle images, you see a food service robot that's paired next to a zipline robot, which in this case is delivering medicine, but could easily be dropping off your latte or pizza or whatever to your house as they're testing here locally with Moto Pizza. And then on the bottom side, you see the Boston Dynamics Spot robot dog, Overland AI, a couple of different applications for that. And then, so what makes the Pacific Northwest special? It's really artificial intelligence. All these robots use a huge amount of sensor data and synthesize them through artificial intelligence. The cloud computing, which Seattle is, absolute global leader in, because all these systems suck in a huge amount of data. And then we have some special institutions, like for maritime, we're talking about Keyport, Bangor, Bremerton, Everett. Those are super critical. And then we've got some unique applications with the ports, hydroelectricity, et cetera. And here's just a quick breakdown of robotics by type. Obviously, Amazon Robotics has been a huge in bringing that ecosystem in, but we have a really robust agriculture and food tech, aerospace and defense, and all sorts of autonomous vehicles as well. And then quick, I'm just going to go through this super quick to give you kind of a flavor of all the different applications that happen in the Northwest. So on the warehouse side, there you see Amazon Warehouse Robotics, Wybotic, which you can see downstairs in our first floor if we get a chance to take some tours down there later on. In the middle there, that chip is a Lumotive LiDAR chip. And then you got Agility Robotics, which is a humanoid robotic out of Salem, Oregon area. Everybody's talking about AI. That requires more data warehouse. All those are heavy and hot, and the data is super sensitive. So there's OSHA human and safety concerns, as well as making sure that data is equipped. And this is the one image that was created by AI, talking about AI. Ag tech, you got Carbon Robotics, TerraClear, and the mushroom picking robot there. I'm going to zoom through these so we can get through quickly. So Picnic Robotics, Picnics here. There's an example from Miso Robotics, and then this is Lee Kindle from Moto Pizza. His dream is that you can walk up, pay at a kiosk, back of the house, a robot makes your pizza for you, and then a drone or robot delivers it to you front door. So someone who's really thinking about the future. We got Space Robotics. This is Starfish Otter Pup. They have this second mission on orbit right now. They have $50 million in contracts for 2026. Blue Origin, Interloon, there's all sorts of exciting stuff going on in space. Maritime, I'm going to skip this slide because we're going to talk about this heavily today. Overland AI doing some awesome stuff on the terrestrial side. Pendleton UAS test range, there's 14,000 miles of airspace for testing autonomous vehicles out there. And then we have all sorts of awesome companies. You got FLIR, you got Electro Impact, and Free Fly Winville that make components to there. So just want to give you an idea of all the exciting things that are going on in Northwest Robotics. And I am super excited to turn this over to two true experts and get this panel off. So Caitlin, you want to come take the mic?
All right. Seems like everyone can hear me. Well, thank you so much for everyone coming out tonight. If you are part of One Ocean Week or from the maritime ecosystem, actually, that might be a good place to start. Who would say they identify with being part of the marine or maritime ecosystem? Raise of hands. Great. So we have some newcomers. So I'll try to give a bit of context. My name is Caitlin Hardy. I'm the founder and managing director of Ness Consulting. We work with maritime and defense tech startups from MVP to commercialization, and we also do a lot of work to help companies abroad bring their technology to the US government. I first started working in maritime autonomy in sort of what I would consider the early days when I was in an undergrad studying naval architecture. So naval architecture is not how the Navy designs buildings, but really the naval or ships engineering equivalent of how ships are designed and built. And at the time, 15 plus years ago, we were really focused on what the IMO, the International Maritime Organization, qualifies as a vessel. So everything that we were doing was 2 meters, 6 feet or under, because if you went beyond that, every nation had their own rules for how we were allowed to test vehicles or vessels and what that looked like. So for today's panelists, I'm so excited, one, to be here at home in the Northwest, because these are all dynamos within their own right across the world. The global maritime industry is quite small, even though 90% of everything, if we're talking commercial maritime, moves by a vessel. So today we're really lucky to have the conversation going from really the bottom of the seafloor for how we bring data together and aggregate it in a faster way, a more methodical way, talking about the different types of vehicles from AUVs or UUVs, that's autonomous underwater vehicle or uncrewed underwater vehicle, then making that transition to the surface side of how are we getting that data, whether we're looking at mapping the bottom of the ocean floor, looking for things in the water column. If we were to go through the full depth of water, what is it that we might see from a target? What is it from a shipwreck that we're trying to understand? Very little of our oceans have been mapped overall. We know more about the moon than we know about the bottom of the ocean floor. And all of these companies are part of telling the story about how do we get to a point where we better understand what our seafloor and what our planet looks like. So I'll come back to why I'm so excited about the panelists, but I want them to each give a quick introduction. We're going to start with Victoria Price-Doucet and hear about StrateSea.
Yeah, so I'm Victoria. I'm the CEO and co-founder of StrateSea Consulting, or sorry, StrateSea Technology. How about now? Yeah. Fantastic. CEO and co-founder of StrateSea Technology, and we are on the data end. So we are bringing sensing autonomy and making autonomous platforms in the maritime space smart. And we are doing that through a platform for no-code AI for object detection, target recognition, basically a way to ingest and analyze and process all of this data that is being collected by this incredible boom of autonomous vehicles that are emerging in the maritime space.
Great, thank you. Moving on to Reeve.
Sure, that worked. Yeah, my name's Reeve Hicks. I'm the VP Robotics at Ramp Robotics. Ramp Robotics is a startup. It's only been around for a couple of years, a spin-off from Mackay Ocean Engineering, which has a long history in the space, innovating in robotics, subsea communications, and sensor systems since 1973. I joined Mackay about 10 years ago. I work after my master's in mechanical and robotics engineering, and have worked on a number of systems, primarily for government customers since then. The ramp system's a little different. It moves us over into the commercial world more so, but it's a combination commercial defense application for subsea anchoring solutions.
Thanks, and Sean.
What a privilege to be here. Thank you very much. My name is Sean Fowler. I'm with Ocean Infinity. For those of you not familiar with Ocean Infinity, it's a UK private company, and it is transforming the way operations are done at sea. And this is an understatement. We've invested almost $1 billion in the build of large uncrewed vessels ranging from 21 meters to 86 meters. We're involved in removing some of the crews and payloads, operating the payloads remotely from a control center in Southampton. We'll get a bit more into that during the panel, but for myself, I'm originally from this area, proud Husky, product of the School of Oceanography. My apologies to all the Mariners fans. I grieve with you. Yeah, we'll go from there. Thank you very much.
Perfect. And finally, Andy.
All right. Also a fellow UW alum, born in Portland, and started my career as an oceanographer, delivering data. And my whole career has been spent focusing on the technology to get more data sets and new data sets. And I kind of evolved into the uncrewed systems, and eventually joined Bedrock Ocean Exploration. Bedrock is a company that was founded with the idea that we can see and do more with autonomous underwater vehicles. And we'll share a little bit about them here. They're low logistics, and they run for about 12 hours pop and collect full geophysical data sets. So they're really opening up the high resolution data access to our world and aiding exploration. So thanks for having us here.
Oh, thanks for joining.
Yeah.
They're hijacking the panel. That may never have happened before with oceanographers. But I too love it. As I said, in the Northwest, we have such a healthy ecosystem, particularly in the underwater side. There's ranges here for the Navy to test vehicles, to test their subs. There's a lot that doesn't necessarily play well together, I would say, because it's such a secretive world historically. So if you're not really from, this side, the undersea side, or even the surface side, and what we frequently call maritime domain awareness, where we're trying to use sensors to understand our surroundings, what's taking place, this is a really unique group to be able to talk through some of these different areas. So I thought that I would, kind of talk through from the seafloor up. So from Ramp, we're hearing about all the different ways that they can quickly anchor into the seafloor. And anchoring into the seafloor today is something that heavily relies on divers, relies on a lot of infrastructure, and it's just really costly to do. And then as we move through the seafloor, we have Victoria's company, which is focusing on how we bring the data together. Andy's company, which is focused on using AUVs that are quickly deployable, right? So there are UUVs at various depth ratings. You can have UUVs that go to the bottom of the ocean floor. You might have a UUV that is, the size of a suitcase and only goes to 100 meters, a few hundred feet. And then finally, with Ocean Infinity, you're looking at what that full ecosystem looks like from an uncrewed surface vessel or a crewed surface vessel, and looking at the launch and recovery systems to drop UUVs off the back and go and run and do a mission. So my first question to all of you is, each of your companies touches a different part of this ocean system. What are the biggest challenges in stitching these layers together into a complete operational picture? And I'll start with Victoria, and if you can help give us a little bit of context as well for those who aren't oceanographers like myself, of what does a traditional mission also look like from your time, such as on Nautilus?
Yeah, so traditionally you have a crewed surface vessel that is collecting data with, they might have a multi-beam sonar sensor that's giving you a picture of the topography of the seafloor. You might have a side scan or synthetic aperture sonar that gives you a picture of what's on the seafloor. It almost looks like a photographic representation. You might have seismic sensors that are telling you what's just under the surface or what's under, going actually quite deep for things like oil and gas exploration. What's in the water column, things that might be suspended in the water column, that might be moving in the water column, that might be fish, they might be other UUVs. And so all of these sensors are collecting data at the same time, and all of this data has to be analyzed independently of each other at the moment, and it's always very manual. And so for every 12 hours of survey that is currently done, there's 12 hours at least of manual target identification. So what is of interest that is in or around the seafloor? And this is really rapidly becoming a problem in this industry as autonomous vehicles are collecting more and more data, and you have fleets of vehicles that are collecting data 24 hours a day, 7 days a week. That is far, far more than the workforce can currently keep up with from a manual standpoint. And so one of the big challenges is that really in this space and how we tend to see really innovation happen and everything kind of happens in silos. And so we've tended to start with sensors first and new sensors and new vehicles. We tend to kind of get further and further away from the mission and what are we actually trying to accomplish and what is the operator trying to look for? What kind of awareness do they need around them? And so none of these systems were really designed to work together outside of, your nav and your IMUs and, motion and that sort of thing. But from a sensor standpoint, nothing really creates that full picture that's really needed for domain awareness. And so one of the big challenges in the space is figuring out how to bring all of that data together across all of these different sensor suites. And this becoming a new challenge also as hardware is really becoming commoditized. There is a proliferation of new sensors coming onto the market every year, really, really cool new sensors, but it also makes it really challenging to keep up with solutions for bringing everything together. And so being able to build sort of a connective tissue, I think is one of the big challenges, so that we can take all of this disparate information and make it into an actual full picture for operator awareness.
No, that's great. And so shifting to Reeve, I would add in, as you see data coming together, can you talk about how anchoring and, holding, we're talking everything from offshore floating wind installations to potentially a place that's still subsea where UUVs go to recharge underwater. What does it look like for how this is done today and what your RAMP micropiler adds and the types of data that you're collecting to be able to do these types of installations?
Yeah, I guess starting with kind of the data collection, we're very much focused on the geotechnical side to be able to understand the when you put an anchor in, what its real holding capacity is. Today, anchoring is not particularly sophisticated in most cases. Put down a lot of weight, put down a big drag, put down a big pile. That tends to be the kind of the common thinking on things with the legacy solutions. What micropiling does is it's put down a very small tendon, steel tendon that's able to carry a lot of load, can take a vertical force on it, be very precise with that. It allows you to kind of think in more of a modularized way or an expansible infrastructure that you're dealing with. So you can start to think about, like in the wind case, what stage one of our installation plan, what stage two of our installation plan, rather than necessarily looking at this like the very, very long lead up in planning, the kind of slow burn to the rapid installation of all the infrastructure. It lets you look at that in a more phased approach.
Great, thank you. And then Sean, maybe to talk through how you're approaching data from your vessels and your remote operations centers all the way to the seafloor.
Yeah, so when I first joined Ocean Infinity, it was about 2018, and the company was embarking in the search for MS-370 in the Southern Indian Ocean, and they had this idea of putting on multiple Hugin AUVs onto a single vessel, which made sense because usually the largest cost in these searches, these operations, is the vessel. So we kind of pioneered the use of that to search large areas. We weren't successful in finding the aircraft. We're going back out to look again in November, but it really set a pathway towards commercializing that, collecting large volumes of data. And dealing with that data is a huge issue for us, especially with the new sensors, synthetic aperture sonar. I think the work you guys are doing is probably a lot of the edge processing stuff that will help alleviate that. And AVs are further complicated from the fact because you're decoupled from the vessel. So acoustic transmission of data, high volumes of data, is just not possible. As for the surface vessel, we have built and are building autonomous uncrewed vessels from 21 meters all the way up to 86 meters. Beyond 24 meters, they're really regulated. You're not able to take all the crew off, but we've been able to remove some of the payload personnel for ROVs, for AUVs, and also for geotechnical equipment. And we deal with the data. I mean, the revolution in SATCOMs over the past 5 years has really changed things. So we have Starlink now, which is high bandwidth, low latency. There's still some big challenges there in getting all that data to the control center. But the idea is to have a vertically integrated system from the surface vessel all the way through the seafloor sensors and the midwater vehicles and consolidate all that data and do some edge processing and get it back to the control center.
Well, great. Thank you so much. And then to Andy, and maybe touching too on the fast speed that you can drop UUVs in the water for getting your data.
I'll get to that. Yeah, the Bedrock Ocean Exploration really started as a data company. Our first product really was Mosaic. It's a cloud-based portal. It's free. You can go to our website, set yourself up an organization, and publicly available data sets are there that anyone can view. So we started there and working with other people's robots, adding data sets as we go, working for different customers. So that's really how we got our start. And eventually it evolved to, we could do better. These things were unitaskers. They did one thing, just multi-beam or just side scan. None of them did sub-bottom profiling in the small scale AUV. So we said, let's do it all in one. And we worked with different sensor manufacturers to miniaturize and pare down their technologies in order to fit our application. And really the challenge with data when you're operating subsea is finding the way to get data, but maybe information to the surface for the stakeholders and the decision makers so they can get that quickly. So that's really at the heart of Bedrock as a data-centric company, really what our focus is. So that led to the design of a small, mobile, easily deployable platform that can gather any data from anywhere in the world. So.
No, that's great. I think all of those answers, you could go a million different directions. I mean, with Bedrock, it's been really interesting to see, I would say, the proliferation of UUVs. There used to be just a handful of companies. I'm really proud to have worked for one of them. But, up until a few years ago, maybe 5 years ago, you could probably count, in the low thousands of the numbers of UUVs that had been deployed. So to see a lot of these new entrants and sort of the democratization of all these different sensors and the hardware that Victoria talked about is certainly something to be watching as you look at, do you want to move into this space? Is there something that you might have a team that's able to support? One of the other things that makes the undersea space very different is, in UAS, we hear a lot about GPS denied environments, but when you're undersea, that's not exactly something. So there's a lot of work around inertial navigation systems and how accurate are your sensors for where your robot is going to surface and what that means when it does surface for how that data is flipped to, SATCOMs. One question for the group that I also find fascinating, this is sort of the second half I would look at of what I was really excited about this panel, is all of your companies are less than 10 years old, but yet you've had amazing success in what you've been able to bring to the market. What have been your biggest inflection points? It could be technical, cultural, funding. I know we have a few VCs in the room that have defined your growth trajectory. We'll go back to Victoria.
I think we're probably the youngest company, and we started in January. It has been a weird and wild ride this year. We've been moving at lightning speed, so I think those inflection points have been frequent at this point. I think really the biggest one, though, was talking with some of our allied Navy customers and really realizing that we had set out to build initially was really kind of workflow automation, and that evolved into thinking much bigger about not just automating workflows and making the process of this analysis and this target identification faster, but how do we think a little bit bigger to solve this problem about having real-time awareness in the subsea space, both from surface vehicles, which is a a more straightforward problem, and also from underwater vehicles and UUVs, and how do we think about that so that when the comms tech continues to evolve and some of those communication challenges are advanced, we're ready to meet that challenge to be able to provide, not just workflow automation, but full awareness in the maritime domain in the subsea space. And so there were some really distinct conversations that happened over, early in the summer that really kind of shifted our thinking and shifted how we think about it from a fundraising standpoint. We're in the middle of a raise right now, and we're a young company, but we've been in this space for collectively 60 years. And so really sticking to what we know are the challenges, and there's a lot of push in the space to go fully vertical from VCs and wanting to be fully vertical, but knowing that the real need is that connective tissue, and sticking to kind of what the perspectives that we've had over the years as buyers of this kind of tech, as developers of this kind of tech, and combining that with those conversations to think about how we use what we know and what we're familiar with to think really differently around this sort of awareness.
And before we go to Reeve, only because you and I have had this conversation before, and I've had it with a number of other friends in industry since, but I think one of the biggest challenges that I see is sort of this perception from the outside world, those looking to enter the undersea domain or the maritime domain, that sort of data is data, that we can pull data from anywhere. And so having all of you lovely oceanographers, what makes oceanography data so hard? Sort of the quick answer there that requires oceanographers on staff to solve these problems.
Can I start?
Well, I'm going to come back to Reeve, but like your 30-second,
Yeah.
maybe we come back. Everyone's kind of looking at me. This might need more meat to it for everyone.
I'll start because I've been answering this question a lot for VCs lately. And it's one of our moats, in that this data is really complex. There's a lot of physics that goes into understanding this data, into turning sound data, other sensor data into a visual representation. And that's something that, especially when you start thinking about all of the different kinds of data and all the different manufacturers and sensors, there aren't a lot of people who have done all of that. And that is a huge challenge in this space. It's a huge challenge for scaling. But it's really complicated data. It's not just imagery. And I think that's something that a lot of folks don't really fully understand.
Perfect. And so going back to Reeve for the inflection point, I know that I was really excited when you all had shared your picture of your micropiler like in the water and some of the testing. I can't speak to what your inflection point was, but I mean, that's such an accomplishment to have hardware in the water doing the job.
Yeah, absolutely. I think there's been a few inflection points that we've seen. You named cultural as the first one. We were born out of Mackay Ocean Engineering, like I mentioned, and that's a long-established, well-established engineering consultancy. Transitioning from the mindset of having R&D projects that typically end at the end of the R&D stage to be transitioned to a prime, over towards something that we're looking with a more commercial outlook, looking from more of a services perspective on it. That's been something that we're working through the long established heritage of that company. When it comes to other areas that the technical challenges that we've come across, we originally started out taking a look at this from more of a conventional perspective, which is a surface supplied grout anchoring system. So we put in the micropile, we send grout down to it. We're able to affix that to the seafloor. But what that clearly was seen quite clearly early on was that's depth limiting for any sort of system, being able to have that surface supply. So one of the technical advantages that we quickly jumped on was an innovation that was by actually my colleague sitting in the front row here, so you should ask him about it later, is a subsea supplied grout system. And then we've also since then evolved to taking a look at epoxy anchoring systems. So the technology's evolved. It's been inflection points that have enabled us to be able to tackle these type of different and more broader depth subsea anchoring challenges.
Great, thank you. Moving over to Sean. So Ocean Infinity, if I have it right, was founded in 2017. So you're the most mature by number of years company up here. What have those inflection points been?
Yeah, we also have several inflection points. I think the biggest one for me was the pandemic. So following the search for MS370, we started to commercialize our multiple AEV solution into oil and gas clients, renewable energy clients doing site surveys offshore. The pandemic hit. We had a vessel in Guyana. We were unable to do crew changes, and the owners got together and said, this is crazy. We have all this technology to operate subsea, and yet we're still doing crew changes. And it really got them down the path of looking at how we can remove people from sea. There's a number of benefits to removing people from sea. It's safer. And you find when you start removing people from vessels to shore, the design of the vessel, the function of the vessel also changes. It reduces. You don't have to have the same house size. You don't have to fly people around for crew changes. And all of a sudden, the carbon emission footprint, really starts reducing. And this is attractive to our clients to have this, technology, lowering emissions. That was a big one for us. And I think along the lines of what you're saying is moving from a tech R&D type company with enormous funding. We're very fortunate in that aspect to being able to convince clients, that we have a commercial solution that is robust and ready to go. That's one of my personal challenges. I need to take all this technology and sell it into the clients. And often the clients are oil and gas customers. They're very strict. They just don't have much tolerance for non-delivery. So the way we've tackled that is to bring them along with the journey, be fully transparent. And many of them are fully bought into what we're trying to do here. Remove people from sea, from safety, carbon emissions reductions, and using technology to do that. But you do need to be transparent, and a lot of them are joining the journey with us.
Oh, that's great. I know on the IMO side as well, right? So there's a lot of conversation, and the IMO has recently said that any autonomous vessel has to still be able to do search and rescue at sea. And so I see that as another level that companies are trying to figure out. If you're lost at sea and you're a person out there, you want to know that a robot ship, I guess, can still come get you. So it'll be interesting to see how those pieces develop. What about at Bedrock, Andy?
Well, I think I'll tie it together there. The Bedrock was founded originally as a public benefit company, and that our focus is really giving something back, to the world. And our outlook is that this ocean covers 70% of our planet. And it's the source of our food. It's the source of energy. It's the equilibrium for the planet. And there's so much information there that we just don't know. So that's a challenge for oceanography, and the seafloor is a boundary, and we don't know anything about that. I mean, there's still subs running into seamounts that are not mapped. So there's a lot for the exploration side, and so building robots that can get seafloor data, was kind of the evolution after building this data pipeline for sharing that information. And so I'd say many of our inflection points are the people that we have working for us. I mean, we're a data company. Yes, we build hardware, and we're an operations company too, but most of our people are focused on the data delivery, whether it's in the cloud, whether it's in the GUI interface, whether it's in the robot itself, taking that data, translating that data, and turning that around. So there's so many milestones and so many points where this works. We got rid of that noise. This works. We succeeded in this mission, and one of the more recent ones, we were running parallel operations in 2 ocean basins with 2 teams, so there's many milestones as you grow, and these are commercial operations. So revenue earning as a startup is another milestone. So they just keep coming, and you think it's fast now. I think they keep coming as you grow and expand as a startup.
No, that's great. Thank you. I'll jump into some sort of individual questions for each of you. I want to go to Sean to talk about you were one of the first when I was at Kongsberg. My absolute favorite pictures, total boat junkie and AUV junkie, was seeing all of the Hugens lined up on your back deck and being able to deploy those. Can you talk about what it was like in those early days and now to operate multiple AUVs at the same time?
Yes, sorry. So the picture you're talking about can be found on the internet. It's fantastic. Yes. So just going back to the story earlier, we knew the largest cost was the vessel. The only way you can search for objects on the seabed in high resolution is to get close to the seabed, and the Hugen's perfect for that. So it flies 40 to 60 meters above the seabed. It can image things the size of that chair in up to 6,000 meters of water. Unfortunately, one of it doesn't cover a lot of area. You cover a swath of maybe 200 meters, 300 meters. So the idea was born to let's put 8 of them down there. So we chartered a vessel, built a bespoke hangar, a launch recovery hangar off the aft end of a traditional boat. This is not our new vessels. but it proved the concept, and we had a gantry system to be able to launch the AUVs over the side. We had some big challenges in positioning the AUVs. One of the early concepts, if you're familiar with subsea positioning, is that you need to send an acoustic signal down to the AUV to get a health check to be able to give it a surface position. We had 8 of those AUVs running around. So the original concept was to build and deploy 8 8-meter USVs to track and follow above the AUVs to give a precise positioning. It didn't work out the way we expected, especially in the southern Indian Ocean. The wave motion was affecting these 8-meter USVs, and it turned out that the inertial systems on the AUVs were much more robust than we thought. And so we just had to do what we call handshakes. So just interrogate one of those AUVs subsea every 4 to 6 hours. And for search purposes, that's fine. When you start moving into engineering, where you need much tighter positioning, there's a whole new plethora of problems. But yeah.
No, thank you for humoring me on that one. We'll come back to where you are in a few minutes. For Reeve, I was hoping maybe you could talk about some of the scenarios where you see micropiling as an enabling technology for really this rapid type of infrastructure. And I know we've talked in the past about some of the natural disasters that have happened around the world, as well as where your tech could fit in.
Yeah, I think there's kind of 2 ways that we can think about that. There's the planned and the unplanned. In the case of the planned, it's again coming back to the concept of modularity, the concept of precision, being able to expand a field of infrastructure subsea and know where everything is positioned. It's a lot like if you think about terrestrial construction, you're building a house. You don't go stick a big boulder in the center and then build the house off that boulder. You like to anchor the key points of that house and develop that in a more sophisticated way. When it comes to the unplanned events, salvage, stabilization. There's a lot of different activities that, if we're dealing with a natural disaster, for example, we have ways to do coastal resilience and installation. We have ways to be able to quickly and permanently anchor offshore aid ships. The ability to go stick an anchor in a place that maybe is not an ideal anchoring position quite quickly in almost any seabed is really the advantage there.
Great, thank you. Going over to Andy, so you also are just a guru and known throughout this industry on, what does it mean to democratize ocean data and bringing it together? And I was hoping you could talk about sort of where the changes you've seen in the last couple of years and where you see, ocean data, the speed at which we're able to gather it, how we're building that chart, that map of the underwater world, and sort of where Bedrock fits in of trying to get that speed for, if we think about, UN 2030, where are we on that target for mapping the ocean floor?
That's a big question. So I think, in terms of where we're at with data, is this working? Okay. Is there's a lot of data that's been collected, and people would be more than happy to share it. In many cases, some is very proprietary and they want to keep it very close to their chest, or some they just never thought about sharing it with anyone else. And so that was kind of at the beginning of Bedrock, is that we wanted to create this repository where data can be uploaded in any format from any sensor and shared and accessible to the world. So having a place for that data is probably a good first step, and so that is why we started with that. And what we're finding, in a business world and in the commercial side of things, is that there's data as a service, there's mission as a service, there's robotics as a service, which is more akin to what we do, and they may sound like different things, and they are very different things, or they may sound similar, but in some cases, data as a service it's collected, as a proprietary thing and sold to you because you need it. Mission as a service, you're paying for the mission, it's our data. You can have access to the data, but it's our data. Robotics as a service, it's your data and we're collecting it. So that's kind of the latter model that we've really been focusing on. And in many cases, when we've collected and delivered the data after some period of time, the clients are more than happy to make it available in the public domain, and we'll have that repository for that. And we're seeing it more and more commercially. I think as a service rather than procuring and buying, 8 Hugiens, people can just hire these 8 Hugiens and get the data that they want. So the what they call contractor-owned services are starting to appeal to the defense side as well, where they don't need these long procurement processes and mil-spec technologies. They just want the data. So I do see the evolution now that these tools are making that data collection a lot easier and making the data more accessible.
Yeah, I guess to tag on to that, because it's a good point for this. So if we look at the COCO, contractor-owned, contractor-operated, or COGO, contractor-owned, government-operated models, but how do you talk about the resolution or sort of that right, like data integrity that different customers are looking for? Is that something you're being asked about a lot of, oh, well, we're going to give it to you at this, if it's your TV, like your 1040 or whatever it might be, right? What's that like?
Well, I think like was mentioned, the some requirements are survey grade, some are for engineering, and they need very precise positioning with that data. In other cases, it's a search, and if you find something, you're going to go back and look at it later. If it's in that area, they'll find it with divers or an ROV with cameras. So that's in sussing out anyone's application. It really comes down to what's the data for, what resolution do you require, and what accuracy is needed, along the way. So it's very much a part of every discussion and every mission plan. Having vehicles close to the seafloor, we have the opportunity to collect the highest resolution data without the noise of the water column. And with modern INS systems and DVL-aided navigation, we can stay on track much longer than we could even 5 years ago.
Cool.
So it's getting better and better, and we can stay under longer and longer.
Yeah, slowly getting there. Well, that tees up Victoria, I think, to talk about, or what I'm hoping to talk about is what are the bottlenecks we see in how we process data today if we're thinking about hydrographers on board, oceanographers who are processing, and what does that mean? Suddenly all of this information from, their vehicles is coming towards, our systems and people, but also like how good are we at finding things? Is the human eye or someone who's tired and working that long shift? Can you talk through that a bit?
Yeah, I would say there's a few different bottlenecks. The first being just the very stagnant labor force that I talked about. And this is a highly skilled labor force, and it's one that has not grown with the data, which has been the scale of the data, which has been really challenging, especially as we've seen a lot of focus on more vehicles, more sensors, more coverage, more data, but that's not awareness, that's not intelligence, that's just coverage. And so how do we actually turn all of that data into useful information for operators is sort of like the next frontier question. And so there's that manual bottleneck, which is what we had initially, step one set out to solve for. When you start getting into the data itself, as I mentioned, it's really complex data to work with. There are a lot of different sensor types. And as there are more sensor types, you really want interoperability. And so that interoperability is the sort of next gate and next bottleneck that we're trying to solve for, where you can plug and play with sensors across vehicles. And that really makes it so that organizations who are trying to do all of these different things across the value chain don't have to reinvent the wheel. And that alleviates that bottleneck of that interoperability, where there's, a sort of standardized way of being able to engage with this data across all of these sensors. And I think the third one is really around usability. And we see a lot of, and I was an academic researcher for a long time, you see a lot of sort of home-cooked solutions that might work. Somebody might build the best target recognition model ever, but unless it's something that an operator can actually engage with and can scale as part of a workflow, then it's not going to be useful. And so we're really focused on building out something that is useful and usable, and really simplifying the complex for operators in the field to be able to engage with really complex algorithms in a way that is intuitive to them. And that eliminates that other bottleneck of the sort of barrier to entry for AI and machine learning, where you need to be a data scientist, you need to have a PhD or whatever, you need to know how to write code. And so that has been a very large bottleneck, where we've seen organizations spend millions of dollars on data science teams and then ultimately disband those efforts because they don't end up with something that is useful as part of a workflow that an operator can engage with, so it doesn't scale. And it also doesn't scale across all of these different sensor types. And so that's been a big challenge in the industry. So I think that there's a lot of different sort of bottlenecks across that data. And then I don't remember what the second part of your question was.
No, it's okay. I know we're getting short on time. We've talked a lot about the undersea side. I do want to come back to Sean for a minute. I was hoping you could talk a little bit about the remote operations center. And as your ecosystem comes together, we talked a little bit about, your workforce has changed. COVID was a big part of that. But what does it mean to have a remote operations center for all of these assets globally?
Yeah, so currently our operations control center is based in Southampton. It's designed, it's a massive building, probably 3 times the size of this floor. It's actually outfitted with proper bridge stations, which is a replication of the vessel bridge on our vessels. There's also what we call the payload section. So these are the operating stations that the remote operators are controlling ROVs, controlling geotechnical equipment, geotechnical drilling equipment. It's interesting, when we first started transitioning to lean crewed vessels, not fully autonomous vessels or uncrewed vessels, but lean crewed vessels of large size, 78 meters, 86 meters. There's a lot of resistance from the people who used to go offshore, right? They used to like their 5 weeks offshore and 5 weeks onshore, and all of a sudden, they're going into an office, and there was a real cultural shame. But we also found there was a lot of intake of new mariners, of new data processors, of new payload control folks that had no interest in going offshore. They wanted to go home to their families every night. So culturally, I think that's a big change. It's also nice to have that expertise consolidated in the control center. So for example, if we're operating an ROV in Guyana for an oil plant, and we're operating an ROV off of California for Equinor, and they come across something really unique or really challenging, within that same room, we have this consolidation of expertise that they can jump on those problems and solve them quickly. So
perfect. Thank you. Well, we are almost at time. These panels always go so much faster than I expect them to. But I'd like to ask each of you, 20 to 30 seconds. I'll start with Andy. But what is a tech that you think we'll see in this space, or that you would like to see in this space 3 years from now?
I think I thought it would be here sooner, but having and seeing robots working with other robots, heterogeneous operations. So having surface vehicles that can deploy and recover AUVs, recharge them, download the data, send it up to Starlink, redeploy the vehicles, and keep these AUVs running without having to send people out to shore. Also, call it robots that can recharge and dock in and around an area to continuously monitor an area for extended periods of time. So those are 2 kind of hybrid
I like that world.
technologies
That sounds great.
that really need to take off, I think.
Thank you.
you stole my answer. No, I think in 3 years we're going to see robots working with robots. We're going to see fleets of USVs coordinating together, and this is going to be scalable. And it's going to deliver a lot more data back to shore. The ocean's a huge place, and doing it the old way is just not going to work. We've got to automate these systems and collect as much data as we can. And in order for that to work, it's got to be multiple surface vessels operating different types of seabed equipment.
Great, thank you. Reed?
Yeah, I think that there's one of the areas that I'd personally love to see is the autonomous vehicles getting fully integrated into the regulatory environment. Being able to work with a vessel opportunity that also has autonomous capability is something that would be game-changing, especially for our technology.
Perfect, thank you. And last but not least.
I would say, also in the vein of collaborative, is federated learning in the AI space across fleets of vehicles. So they're learning from each other and from the data that they're collecting. I think that also still relies on the comms piece. So my real wish list, much more than 3 years away, is quantum-enabled communication to address some of that disconnected environment issue.
Perfect. Well, I know that was fast and furious in 45 minutes. I think if we look to, say, even 10 years ago, we used to talk about as mowing the ocean. And there's only so many vessels globally that are going out and running those lines, understanding what it looks like underneath our seas. Now being able to have the proliferation of AUVs, the question really comes down to sort of what you hit on is, how do we make sure that they can operate in this continuous fashion that doesn't necessarily require people? How do we get batteries into a smaller, payload or a smaller form size? How can we bring more payloads? How does that all translate together? And really the data side of then how does that inform us for what we do next? So I want to give a huge round of applause to our panelists. Thank you so much for your time. And also thank you to Craig for hosting us all, and the Fresh team, Kurt and Anna, who've been fantastic in the background pulling all this together. So.